Hello and welcome back to the lab. Today on the bench we have a Tech Type 555 dual beam scope. There are some of the 500 series plugins that I need to get up and running in the lab, specifically a W plugin. So really hoping I can get this scope up and running. I'm breathing a little heavy from moving this thing around. This is not light. This scope is obnoxiously heavy. And my bench isn't small, and you can tell this thing is towering on the bench. It's the same height as this entire stack, scope, meter, and frequency counter from the modern stuff. And it has an associated power supply that's not even in the frame. So we have the power supply unit, and we have the frame, and I do have the interconnecting cable, which is important. So what we're going to do, we're going to wipe down the face, clean up some of these plugins. The plugin that I need to get up and running is a W plugin. It's a differential comparator, but it has some pretty amazing DC offset to it. So we're going to try to get that run. These plugins were not stored the best. There's some corrosion on the BNCs. A couple other things we can see how badly this looks. Oh, come on. That needs some grease. Oh, that's stuck. This hasn't moved in a very long time. Holy cow. Yeah, these rails need cleaning. This needs some lube and everything like that. I was working on a 850 or a 585. I'm not going to put that back in until we get some grease on the rails and clean it up. But I found out the 585 wasn't going to take the plugins that I needed, so I needed to switch over working on the 555. So first things first, anytime you get one of these scopes, the fans need service. It's a oil light bushing, or it's an oil bushing, and odds are probably good it's dry and or crusty. So if you spin them up the fans without lubricant in them, it's just going to destroy the fan. It's going to eat the bearing, and it's going to gall up all the metal, and it's not going to go very well. Those fans are not very sourceable right now, so kind of makes it interesting to find those. So we'll get this flipped around. We'll service up the fan. We'll also service up the fan in the power supply. Don't want that to overheat either. And then we'll put some power to this. See what we're working with. All right, to get into the fan, we'll take the air filter off. We will clean out this air filter if everything goes well. Figure out what just popped out. Probably some spacers. Some labels, which are long dead. Here's our fan. Bearing doesn't feel too bad on this one. Gonna give it a bit of oil anyway. Much better. Work that in. Bit more. Oh yeah, much better. There we go. It was starting to get dry. That's good shape. So we have shock mounts here, which hold the fan and everything, keep it from vibrating around. And then this fan shroud comes out. And a little bit more, because this has been sitting for a while. Oh, that's a little too much. Now we're starting to ooze out. All right, we'll get the cover put back on the power supply, and then we'll do the main unit, because that is next. It should be known that if you're going to open up one of these power supplies, you are doing so at your own risk, especially in this power supply itself. There are absolutely lethal voltages in here. Lots of vacuum tubes. This scope has over 100 vacuum tubes in it. So an absolutely amazing amount of power goes into one of these. The scope runs at about 800 watts. And there's enough iron in here to source a tremendous amount of current. So if you're opening one of these up, you are doing so at your own risk. Please take care. I am not what you call a professional, and this should not be considered professional advice. All right, we will get the cover put back on here. And these snap in like so. Now, this power supply has an umbilical cable that comes up to the scope. So we're going to set this aside for now. I'm going to get a hand under it. God, that weighs a ton. It really is heavy. And don't trust the leather hand wraps picking those up. That's why I had my hand on the bottom. That was supporting most of the weight. Those hand wraps, or those handles, are dead at this point. They will not support the weight of the scope. So if you're trusting the handle on any of this vintage gear, it's going to hit the ground. Okay, next stop, the back of the 555. Pull this out of the way, another filter, and we have our fan. And this is a little stiff as well, so this is going to get some oil. Now, one of the things that's happens to these is there's a front bearing that's really easy to get something in there and sneak in an oil. There's a rear bearing that's a lot harder to get to. The easy way to get to the rear bearing is to actually take the fan shroud out. This whole thing will pop out. You can get to both sides pretty easy, which is what we are going to do as soon as I find an appropriate screw removal tool. There are a ton of tubes in here. Holy cow. Would love to save this fan on the 585. The fan bearing, they actually died. It must have been turned on before it came to me because the fan was locked up solid. I tried all the tricks in the book to get the bearings to free up, and it just did not. That video is currently on hold at the moment. If you guys would actually like to see that video as it sits right now, go ahead and leave me a comment. Just let me know, and we'll get that edited up and posted up to the YouTubes. So it's annoying. You guys, I'll have to bring you over here. There's not a ton of room to see, but there's two holes. One there and one up there. That's where the oil goes for this particular fan motor. So I'm going to get that done, not on camera, because I cannot work around the camera and hold the fan at the same time. I do not have 5 hands, but we'll get this loosened up and go from there. It's moving much better after a little bit of oil, so happy about that. Definitely needed the service. Put this back on. All right, I'm going to go grab an umbilical cable, and we're going to work on powering this up. We're going to power this up on the variac and isolation transformer and current limited supply, because I'm not sure when the last time this unit was turned on, but it needs to wake up slowly. I may have to rethink where I'm going to put this, because the umbilical between the power supply and the scope is kind of short. So I was going to put the scope on the floor. I don't know if that's going to happen now, but we're about to find out. Notches are up top, so you cannot put this in backwards, which is good. Oh, actually, you cannot put this in backwards because the... Oh. All right, let's see. That goes in like so and locks in. Okay, that's in. Power supply next. All right, we're going to let you guys watch. Kick this on. It's on the isolation transformer and the variac, so it is cruising. And we're going to bring this up slow. All the bulbs are switched in, so I have 3 amps, but that's not going to be enough for this scope. So we're going to see what it does. We will park it at around 20 volts and let it go for there for a little bit. This has a linear power supply, so I can do a slow startup. You do not want to necessarily do a slow startup with a switching supply, but a linear one is totally fine. We are getting some reforming action happening because I've got 36 volts coming out of the variac and I've only got 22 volts going into the power supply. So it is cruising up. We're going to let it sit for a little while we take a look. This was last in the Atlanta Repair Center for Tech on 6/22 of 66, and it's due again on 6/22 of 67. So the last time this scope was calibrated was 60 years ago. Bandwidth-wise on this guy, I believe we have 30 megahertz on this one. It is a 10 nanosecond rise time on the main unit. So not too bad for being this old. All right, we seem to have stabilized, so we're going to give it a bit more. At 55 volts on the variac, I am seeing the faintest glow coming out of the current limit, and we're holding at 35. Even with my current limited supply with 6 light bulbs and about 3 amps, this scope is not going to be able to start on the current limit. We're going to have to kick out of it eventually, because through the bulbs, it's just not going to have enough go to get this scope excited. This thing is a monster when it comes to drinking some power. All right, at 80 volts, we're starting to see some pilot light action. We should start having some tubes warm up. Not enough to get it going yet, but it should be getting close. Okay, we're up to 120 volts on the variac. We're at 65 volts on the unit. It's drawing 100 watts of power. So I'm going to let it sit here for a little bit, let everything kind of calm down, and then we're going to have to kick it out of current limit mode, give it full line voltage, see what happens. You guys will be here for that, because if anything exciting happens, I want to catch it on camera. All right, everything seems to have stabilized, so we're going to go for broke. Hit the bypass, full line voltage. We have 113 volts into the scope. Going to give it a bit more because it wants 117. Heard the click. I can smell the warm. Let's see if we have a display. Should have a display. We have scale illumination. But it doesn't look like I have high voltage yet. Well, we're doing some troubleshooting in this triple nickel, and I'm getting really close to the CRT, and I really don't like it. The weird part is both guns are dead, so I can't get an upper beam or a lower beam. I've got good, you guys should be able to see that, I've got good 150 volts, negative 150 volts coming out of the power supply. We'll check the AC side of things on the filaments. This is going to take a minute for the power supply to kick on. There's the click. High voltage comes in. Filaments are running 6.7 volts. They should be 6.3, so they're about 0.4 volts high. And I have already checked the high voltage, both high voltage supplies, and I actually have upper and lower high voltage. What I'm not seeing is glow from the CRT. So I am starting to think my filaments might be dead in the CRT, which if that is the case, that is going to be a terminal failure of the unit. All right, there's a real quick test on the front of the scope if I'm getting high voltage. I've got cathode voltage. I may not have anode voltage. We're about to find out. This is a test you can do on any CRT and doesn't require any tools. There's the click. Nope. Actually, I do have anode voltage, so that's weird. So the way you find out is just run the back of a hand close to the CRT. If you have high voltage, the hair on the back of the hand will stand up. So I have anode voltage. I have cathode voltage. I have no beam. These lights are indicating sweeping, and these lights are indicating that I can move the beam up and down. Yet I have... So I'm back to filaments. I think I'm starting to think the filaments in this tube may be gone. Actually, it's looking very much like the filaments in this tube are dead. Well, it doesn't happen often, but sometimes we do run into the unfixable here in the lab. And we have run into that this evening. Been doing the troubleshooting, taking a look at this, and through the back of the unit, there is a way to get in and view the back of the CRT. And the back of the CRT is not glowing. So that does confirm we have a filament problem. The CRT is not getting hot, so it's not boiling electrons off that it can then smash into the phosphor at the front of the screen. And what's very odd in this case is both guns are dead. I'm not getting any filament action on the upper or lower gun, and my 6.3 volts is there. So this one is unfortunately going to be a terminal fault. I was actually looking forward to getting this one up and running for the lab, but we'll stick with the HP that we got going in a previous video for a while and continue to go on. I will keep this unit around for a while, see if a CRT pops up. I highly, highly doubt a CRT is going to come available for this particular unit. At least that's not one out of a donor unit or something like that. But we'll keep our eyes open, see if we can get some parts. Maybe get this thing up and running again. I checked my CRT stock. I have a fairly large one, and I did not have the appropriate tube in my stock either. So we've just run into some unobtainium parts, and there's not much I can do. If you'd like to support the channel and what we're doing here, Patreons are running about 5 videos ahead at the moment. So take a look over there. Everything will wind up on YouTube eventually, but their support to the channel helps immensely, keeping the lights on and keeping the projects coming. The repair queue has just gotten extensively long, so we have some really cool stuff coming, and getting into some non-Tektronix equipment, which should help keep it interesting. So, with that, I will see everybody in the next video, and hang around. Well, after closing out the video on this 555, I wanted to just double check and make 100% sure that we did have a CRT problem on these Tekscopes. This is such a strange, odd fault. Everything was pointing to it, and the logic was leading me down that path, but I just wanted to confirm it. I was able, it's way up here where the CRT is. The scope's been off for over a day, so I don't need to worry about voltages or anything like that. Way up there is where the neck of the CRT is, and I was able to get up there and actually get some meter probes in with these long test pins. And when I checked both guns read extremely high. Heater voltages are usually in a couple of ohms, and the heater resistance is usually in a couple of ohms, things like that, because they need to draw a heavy current. And then as they warm up, they go high in resistance. They're a positive temperature coefficient resistor. The cold heater voltages on this heater resistance on this tube is One side is 40 k ohm. The other side is 20 k ohm. So with kiloohms of heater resistance, that's going to be a 100% confirm. We have a dead tube in this scope, and this one's going to be done because the tube is unobtainium. So, my quest for a 500 series that works with a W plug-in will continue, and we'll keep looking. I did also find out that the W plug-in will not work in the 585. The pins are different. They actually flip the pins on the back of the plug-in. They will not be compatible with each other. So, more is on the way, and we will dig into some more things out of the storage pile.